Hello everyone and welcome to my channel Octopus Math by Sahiba. So in this video we will be learning about the definition of logarithms and some basic rules about it and a little practice of those rules. So a logarithm of a number is the power or index to which a given base must be raised to obtain the number. Okay, this is a very complicated definition. Now let me explain you how the things are. Now, what happens is that, first of all, let's take a look at this exponential thing. Like we know we can write a number in its exponential form as, for example, let's say 8 to the power of 2 is 64, right? We know 8 to the power 2 is 64. So here 8 is acting as a base because there's a power on the top of it. So 8 is acting as a base, 2 is the exponent, and 64 is the value, which means the base when raised to the exponent, certain exponent gives us a value, which is 64 here in this case, right? So I'm just trying to explain how the things are. Now, this exponential value, when transformed into a logarithmic value, it tells us that log of the value, which value? This value we're talking about in this particular case. So log of 64 to a certain base. Now, which base? This base we're talking about is actually 2. So we basically have to read it in this logarithmic form in a way that 8 to this power gives us this value. So this is a certain way of writing the logarithms. Okay, 8. If I say that 2, 8, what could be what could possibly the answer? So we have to think it that way, that 2 to the power what? Okay, what gives you 8? So 2 to the power 3 gives you 8. So that means it's 3. Now there are certain rules, there are certain rules, or you can say laws, on performing logarithms on different numbers and variables. Okay, so let's take a look at those. So I want you to keep your scientific calculator with you, so you will be able to easily understand what I'm trying to say. Okay, so quickly, we need to see log. Okay, log always come with a little base here. Okay, if the base is missing, it means by default the base is 10. So a lot of people write it as, if there is log, let's say x to the base 2, it's fine. But a lot of people, especially in this book or any other books, if it just says log x, that means there's a small hidden 10 here by default, which can also be written as lgx. So which means there's a small base. Lg actually means that the base is 10. So lgx is the alternative of writing this. So, it will not be a smarter way to write it like this. If you want to keep the base hidden because it's 10, so it's better if you write it like this. But it's okay if you keep it here. So I was actually telling you that log comes in bases, right? So I want you to quickly see if log 1 with any base, you can write it down any base, because the calculator would not allow you to write variable base. You may notice that there are some variables in your calculator, but those are not actually uh, that. It basically tells you to save some values in the variables and then solve it, but it's okay, you can write on any base. Let's take base 5. Okay, so I want you to calculate this, put it in your calculator and see what happens. These and this. Okay, so I want you to see with any base. You can call it 5 or maybe 10, whichever base you want. You can get a base of 23 also, any base. All right, and then I want you to see if any negative number, let's say negative 5, any base to any base, let's say 2, and log of any negative number or any number, let's say 52, any random number this is, with a negative base, it could be negative 0 or anything. And then I want you to see, these are the couple of observations that I want you to see, and then we can proceed to the laws. Okay, let's take a number 25, give it a negative base, or give it base 0. Okay, and then there's negative number with negative base. Also, I think I missed out one thing. Just see any number, let's say 42, to the same base. Okay, now I want you to see what happens. Now this is going to give you some decimal value, and it's not definite, so it's fine. I just wanted to explain you how things are. Okay, so basically log 1, if 1 to the base 5 is going to give you 0. Log 0 to the base 23 is indeterminate, or you can say that it's undefined. Your calculator may give you math error. For log negative 5 to the base of 2, this, when you input in your calculator, you will get math error. That means it's undefined. It's because of the the definition that we did. This, you will see that it's again undefined. I want you to look at the patterns, okay? Log 25 to the base 0, again, you will see that it's undefined. Log of, again, the negative numbers with negative bases, again undefined. Please identify. Please note down these patterns. And log 42 to the same base, you will see that it's 1, right? Now coming to the rules in logarithms. Logarithm, when applied on a product of a number, let's say x, y, two numbers are multiplied and then a logarithm is applied. There's no base. I'm just writing a random base by default. So what happens is, in algebra, we basically multiply this, and it's like, for example, if this log was not a logarithm but any variable kind of thing. So what we would by in algebra we would write it as this, right? So it doesn't happen in logarithms. It's different here. It doesn't happen in logarithm that you multiply log a by x and y both. It's not like that because it's not multiplying. Log is basically a function that is applied to the product of x and y. And when you try to apply it on the product, it splits with both the numbers with a positive, that means addition sign in between, which means when log is applied on the product of a certain number, it applies on both the numbers inside the bracket, okay, and then with an addition sign in between. This is the first rule. And let's see the example. For example, if log 5 to the base, let's say 24. Let's see how this is, okay? So you can write 24 as 3 times 8. So according to the property, log is distributed to both inside, the numbers inside, with an addition sign. So I want you to quickly check the value of log 5 to the base 20, log 24 to the base 5. The value of log 24 to the base 5 is 1.97, right? And if log 24 to the base 5 is same as log 3 to the base 5 plus log 8 to the base 5, the values should match, right? So let's see, let's put it into the calculator. So log 5 to the base 3 is 0.682. The values will be rounded off because the values will not match exactly because I'm rounding off the values here. So, but at least we will get the idea that it's same. The value for log 8 to the base 5 is 1.292. Okay, so when you add them up, 1.292 plus 0.682, you will see that it's exactly approximately 1.97. So if I would have written, the whole thing in this, thing in my calculator, I would get the exact same answer as log 24 to the base 5. But because I chose to write round my values to a certain level, so that's why it's coming like that. But it's okay. We actually found out that this property satisfies here. Okay, now the next property is log. If it applies on a ratio of a number, so it will definitely distribute with the same base, but with a subtraction operation in between. All right. So I'm giving you a value. I want you to check it. So let's give it any base. Let's call it other than 10 because I want you to experience this with other numbers. So let's say 8. Okay, 8 is a good number. So I want to give you a number 0.4, right? So calculate the value of log of 0.4 to the base 8, and you can also write 0.4 as 4 over 10 or 2 over 5, whichever you want. Both ways you'll get the same answer. So let's say 2 over 5, and then according to the property, it should be this with the common base, which is 8. So I want you to see if left and right side both are equal. Now the third property is for a power. Like there is a certain number with a power. Let's say the power is m. Okay. So what happens is that the power is shifted behind the log, and it's written as this. Okay. Now writing this may not be same as this. These may not be equal because if you put it down and put it into your calculator may misread as the x is multiplied to m first and then logarithm is applied, or the logarithm is applied only on x and then the result is multiplied with m. So, it may cause a little problem. So it's always safe to write what's best. So writing m behind could be the best thing. All right. So the next thing, okay, let's try this also with with an example. So log with a different base. Let's take 12 this time with this base, and we're going to pick a number. Let's say 5 to the power 3. Okay. So this should be same. This should give us the same value as this. So I want you to check it out and let me know in the comments if you're getting the same answer. Now, the fourth rule is about change of base. Now, all right, for the rule number 3, this works with fractional powers also. Let me give you an example that we know that uh, cube root of, we know that, let's say cube root of m is the same as m power 1 over 3, right? So if there's a logarithm applied on m power 1 over 3 with a certain base, let's call it x. So you can also say that 1 over 3, the power goes behind, and then log m. This works with, sorry, I mistaken. So this works with fractional powers also, decimal powers also, whatever it is, okay? Right, so the fourth power is about change of base. So let's say that log a to the base b is a number, okay? And then you can also write it as 1 over log b to the base a. I'll tell you why this happens, okay? This happens because of one common thing that first we need to see what this is. This means, this actually means that log a over log b to one common base, because log always happens with the base. So there's base, the base is absent. We could uh, give it any base. So maybe you could give it a number or a variable, whichever you want. So let's call it C. I'm going to make sure you give it, the base you're giving to the numerator, make sure you give the same base to the denominator. Otherwise, the property would not satisfy. So log A to the base B is basically the same as log A to the base. So this is the story of the left side. Okay. Now, if these two are same, that means that their results have to satisfy each other, right? So 1 divided by log b to the base a. So you can also write it as log b over log a with a common base. So let that base be c, right? And because it's 1 divided by log b to the base c divided by log a to the base c, you can also write it as log a to the base c log b to the base c. And 1 times log a to the base c is same as log 1 to the base c. And you see that this left side and right side both are equal, right? Thank you for watching. If you like my video, share it with your friends and spread the knowledge.